Hello friends, welcome to Technopoints. In this video we are going to learn about Room library in Android. So Room library is basically, it is not a database, it is actually uses SQL database internally, but it just provides us a convenient way to interact and perform operations in the SQL database. Google has provided this library which works on the annotations. Earlier, before Room, we had to use the inbuilt classes of the SQL database and then implement those in our application and then provide our own implementation, and then we had to perform lot of steps and lot of boilerplate code in order to make a connection to the SQL database and write some queries and make some DB operations. But with the Room, Google has made our life easy by providing this library, and it just works on the annotations, which reduces a lot of our boilerplate code. So instead of writing a lot of boilerplate code, we have just been provided the annotations, and we'll just pass the required values in that, and Room will automatically generate whatever the code it will require behind the scenes. And now it is very much convenient to use the Room library to make our database connections and to use all the DB operations. So this tutorial will explain everything right from adding the dependencies to how to perform the insert, update, basically CRUD operations in the database, how to establish the connection, everything you need to know about the Room. So let's start. So here I have created a new project for the Room library, just an empty project, and we first have to add the dependencies for the Room library. So let's go to our build.gradle model level file, and we have to use this dependency. I am just pasting the dependencies in the description, so make sure to copy from there. So these are the dependencies which we need for this tutorial. This is a room related dependencies. This is the latest version of the Room library, and this one, these three are the room related dependencies. This is Kotlin annotation processing for the Room library, and for that we also need this plugin id kotlin-kapt kpt. Just include that at the top in the plugin section and click sync now, so that Room will get integrated in our project. Yeah, the syncing is complete, and now we can directly use the Room library in our project. So this is the simple simple application with the main activity, just text view. So instead of we'll not be creating any some UI content here. Our focus is mainly just to understand how the Room works. So we'll produce all the results, and I'll use the Locket and other app inspection tools to show how the our data is being added to the Room. So we have added the dependencies, and basically what we are doing to do in this tutorial is we'll make some table, that is let's say table of products, and we'll add different products in that. We'll add 3 to 4 fields in that, and we'll make some DB operations in that table. So for creating the table, we'll need one data class. So just right click on this one, and Kotlin class file, and let's say product, and we'll need this data class. Okay, and when we need some fields here. Let's say val name, that will be a name of product, that is a string, and another one is price, that will be let's say double value, and another, yeah, the two things are I think sufficient for understanding. And the third one, which will be an id. So our DB has the ID, and this ID will help us to uniquely identify our product. So this ID will be an integer. But in the DB, like MySQL DB or other DBs, basically I have used mostly work mostly with the MySQL. So in that we have the facility to make the any key primary, and the database will automatically assign it some unique ID. So we have been provided this through the Room with the help of annotations. So we use the annotation here to declare some field as a primary key. So we'll declare this ID as a primary key. So let's say primary key. It is coming from androidx.room. So we'll just click on this one. So dependency will be automatically added here, and here is a primary key, and it will be applicable whatever the field following this annotation. And in this primary key, if we want the room to generate auto generate the keys for our id field, so we can also define that in the brackets, like auto generate true, false, or we can use any value here. We can use here auto generate equal to true, so that it will be automatically generated even if we didn't provide any value to it. Or we can also provide some unique value, and if we are explicitly passing it a value, so we have to make sure that this is a primary key, and it will not accept any duplicate value. If there is any duplicate insertion, it will throw an error. So what we will do, we will make this integer value a nullable, and we will not pass it from our insert operation. So that's why I have put here at the last, so that we'll just provide these values for these two fields, and this will be an empty. We will not pass it. And as I have initialized it already as a null, so it won't make us compulsory for passing a value for this field. So this is our data class currently, but how room know that this is the table we have to create? For that, we also have an annotation, that is entity, that is also coming from androidx.room, and we'll just enter. So once we declare this entity as an annotation, room will understand that okay, this is a database I have to create with this all these fields, and there is a compulsion that we have to declare at least one primary key for each table. So our table is complete. Now we need one DAO, data access object. That is one of the concept in the room library to understand how we have to access this data, access all these fields in this table. For that, we need some type of data access object, and we're now going to create that. So just create a new kotlin class for that. We'll make it as product DAO, data access object. It is just short form I'm using, and it will be basically an interface. Just click here. So it has generated as a product DAO, and we also have a room annotation DAO for this one, so that room will understand that this is the data access object, and basically this is the place where all our queries will be listed. Whatever the operations, insert, update, delete, read, all the operations will declare here itself. And for that, we don't need to write a lot of code. This is just the interface, so that implementation will be automatically generated by the room library itself. So let's see how it helps us. All the operations here will be suspend operation. So the working with the database will happen on a separate thread, and it will be for that we have to mention on function as a suspend function. If we are using the database, then we live data, then we don't need that suspend keyword here. It will be automatically handled by the live data. But as we are not using the live data here, we need some type this suspend function. So let's say we have to insert the product. In this suspend function insert product, and we'll directly accept the product parameter here, and it is not going to return anything. And as this is an interface, we are not going to provide the implementation for this one. We just have to annotate this with insert, that is coming from room, and that's it. Yes, our work is done. It once we'll provide the value for this one, to this function, a product object, it will automatically insert in our database in our table named product. So all these things, all these background things will be automatically handled by the room. And we can also make other for updating, update product. We'll also accept the product here, and we'll use the annotation update here. So these are the two functions here. But in the earlier new versions of the room library, Room has provided us a different annotation to combine all this insert and update operation. That annotation is upsert. Insert plus update, that is upsert. So we can directly use that, and we can also will also update this function name also, upsert product, and we don't need this update, because what will it this annotation will do, it will uniquely identify the item based on the identifier we have provided, that is a primary key which we have passed here. It will check if this item has already the primary key which is it has primary key which is already there exists in the database. If so, it will update the contents of the other fields of the table with the new object provided by this one. And if there is not, if some another new key has been provided, then it will directly just perform the insert operation, and it will perform the it will add a new product to our table. Now this same single query will do both of the operation, insert plus update. Now let's say we have to delete the product, delete product. It will also accept the product which we have to delete, and it will delete according to the primary key. We have annotation as a delete here. So that's it. It will automatically delete it. And let's say we'll perform some type of uh, read operation here. So here is a one read operation. Will provide the get products. This will not have any parameters. Instead, it will return a list of product, and we'll annotate this with query. If we have to explicitly perform some operation with the help of SQL query, then we can use this query annotation and write our query inside this parenthesis in the double quotes. So in the double quotes, we will write select star from product, and it will provide us the list of products, whatever the products we have inserted. So as you might have noticed, this product, while I was typing, it is giving me an auto suggestion. So this query is not like that, like a normal string that in the double quotes, if we are writing this, then it will not be checked at compile time. No, it will be checked. If I have write something different here, it will show me an error. So this is also checked at compile time itself. So let's say we have all covered these CRUD operations, and we need some another class here for declaring the database, because we have declared here a table, we have declared here the product access object, but we also need some database class, because one database can have multiple products, and the database should know, one database should have multiple tables. So that's why we need another database class here. Let's say I'll mark it as a product database. So this is a product database class, and it will extend from room database. Room database, call a constructor here. Basically it will be a abstract class, because room is there to provide implementation for everything. Sorry for the spell mistake, my bad. And we also annotate this with uh, yeah, database, but this annotation requires some parameters. So let's say what parameters we need to pass here. It is asking for the array of entities, whatever the tables we are going to declare, we are going to use in this database, we have to declare the array of this all that uh, entities one by one. So that's why it is accepting an array of infinite length. So we have only one entity here. So we'll provide product, well, it will be an array. So we'll provide it in array product colon class. And another parameter it requires, that is a version. We'll provide it with the name entities equal to product class. Okay, and another parameter we have to provide is version. Version equals to 1. We are providing 1 for now. So what is this version? Basically, this version is for the current schema of the database. Whenever we are going to change the schema later in the future, we have to upgrade this version from 1 to 2, 2 to 3. These are integer values. We have to upgrade the version every time. And let's say we have just installed our application in our phone, and our application went to live. Now we have to add few more fields, change the schema of the database, or we have to do some alterations between the columns. Then we have to provide something to let the Room database know that this version is different, because it won't automatically identify, and our app might crash. So we have to provide the database migrations there. So we are not going to cover that in this video. I'll create a separate video for the database migrations. For now, just consider that we have to provide some integer value here. So we have provided the 1. Here we have to tell the database that we are using this product now here. So whatever the product data access object we have mentioned here in the separate class, we have to tell the database about that. So we will write private val product tau, the product tau. So the database will also know that yeah, this is a data access object that will be used, and it will also be an abstract. Sorry. Let's remove this private. We don't need it either. Okay. Now we have to initialize the database here in the database class. We have to provide the initialization for this one, but that initialize so that any class can get the instance of the database and access this product now and can perform the queries. So that, and once it get the access to this product now, we will be able to access all these queries. So for that, we'll be using a singleton concept for that, and we are using this companion object here, so that it will be it should be statically accessible from any class. So inside this companion object, we'll provide some database instance, private val db, sorry, not db, only instance. This instance will be of this same database class type, product database, and it will be nullable at the starting, and we'll declare some function here, get instance, and it will return the instance of this product database class. Inside this function, we'll check if the instance is null, and if the instance is not null, we'll directly return the instance, that is database instance, so that only one instance of the database will be created. We'll assert this, that because we know at this point it won't be a null. So insert if this null, then we have to provide the implementation. So it will, how will do that? We'll use room dot database builder. Inside this, it want a context. So we want the class to pass the context while getting the database instance. Context of type context, and we'll use that here. Another parameter context, and dot, sorry, dot. Let's see what else it needs. It needs a class, that is a database class we will be using, and it needs a name string that will be a name of the database, the name of the database file. Here it is written. So let's provide it with the values. It will be a product database, and later it needs, okay, sorry, we need to make this as a class. So Java, and we can provide any name. This name will be name of our database file, which will be automatically generated. So we'll give it name as product db.db. Extension is not necessary, but we can give extension product db.db, so that the file will be generated with this extension .db. And dot bid, so it will give a database instance in the value, callback value, and we'll assign that to the instance. Okay, we have to make this at a pair to reassign it. Okay, now we are set up with the database. We have here set up the database here. We have set up the entity here, that is a table, and we have set up here data access object here, and declared all the queries we will be using in our application. We can change the queries whenever we want. No issues with that. So now let's go to our main activity, and at first create the variable late init var db instance. It will be of type product database, because we want the instance of the product database class. And here we initialize that db instance equals product database dot get instance. We can directly access here, you can see here. So I'll just click it, and it requires a context, so I'll pass it this. And yeah, the db instance will have its value here. db instance, we have already got that instance. So we can use this db instance and then access the tau, and then access all the queries inside that. So we'll try to insert all the queries here. db instance dot product DAO. This is the same product DAO which we had declared. We can control click on this one, and we'll navigate it to this one, product database class, and in the declared DAO. So coming back to the main activity, dot upsert product. We can insert the product or update the product. We can just upsert the product, and we can pass the value of the product object here, which we have to insert in the database. So let's pass the value product name. Let's say it's a pen, and its cost is 10.0, and the third value is optional, and we are not going to pass that because that is an id that will be automatically generated by the room library. So this is done, but here it is showing the error because it is a suspend function, and suspend function must be called from a coroutine. So in order to use the coroutine, we are using the lifecycle scope.launch, and the error will be gone. We can use that in the coroutine. Okay, if you can't understand what it is lifecycle scope.launch and don't understand what is coroutines, then I have already made a separate list for separate playlist for understanding coroutines, so you can check that out. In the I have put the link in the description itself. So we are now good with the insertion. So this will be inserted. Let's create four more. Second one will be second one will be a chair, and the chair will cost let's say 400 rupees. Okay, now third product is, let's say, laptop, and laptop let's say it has costing of 35,000. Fourth one, let's say table, and it will cost 5,000 rupees. And the fifth one, what should be, okay, let's click on uh I'm really not getting which one. Okay, mobile phone, mobile, that will cost around 10,000. Okay, that's it, our list is ready. And in order to see the list, we'll use some log statements here. I'll create one log here. So let's make this log as a main activity room, to make this tag a unique RWM. And here in the message we will write product list, and here we'll be able to access all the products with the help of our query, that is this one, get products. We'll use this query again, the db instance dot product dot get products, and it will show us the list of all the products in the log. So let's try running our application and see how it works. Okay, my emulator has been started, and I am launching this application, and also I'll open the logcat here, main activity. Here will be it as main activity room. So our application is getting ready to launch. Yes, it is launched. We'll just see here the main hello world, but in the logcat we can see the results. And yes, we are able to see the results. All the products have been inserted here, and let's see if we have the same values. Here is a product name, pen, price 10, and id. See, it is automatically generated by the room library, id1, id2, and all the further ids it will generate, it will be automatically generated, and it will be a unique. Another one is chair, third one is a laptop, fourth one is a table, and fifth one is a mobile phone. Yes, we can see all the product list here, so that it is all the products have been added successfully. But what if we have launched this application again? Let's see. Application launched again, and you can see here in the logcat, will the products become duplicate? Let's check it. And this is the third one, this is fourth one, this is fifth one, and yes, the products are duplicate. 6, 7, 8, 9, 10. So there are total 10 products in the database with the same values, but the IDs are different. The main reason behind this duplication is that we haven't provided the ID here. That's why Room has considered these records as again different records, and it has just performed the insert operation instead of update. So what we'll do here now, we'll pass the ID values here. So let's pass here 1, 2, 3, 4, and 5. And now restart our application, and again check the logcat here. This is the latest one, the below one, and we can see the list is same as previous. It haven't already again generated the records because we have provided the IDs. So Room checked internally that okay, this ID is present, then let me perform the update operation here, and as we have kept the content same, we can't see any difference here, but it actually has performed the update operation on that. It has updated the data for all of these IDs, and thus it duplicate IDs, duplicate records have not been generated. So this is we are seeing with the help of logcat, but we can also see a live database here while running our application with the help of our Android Studio. So how? Just click on this app inspection and wait for a few seconds. It will automatically detect that our application is running and it has a database. So it is slowly coming and it will show entity here. Yeah, just double click on this product table and we are able to see the product here. There are 10 records here and we are able to see that here, all of these records. So that's how room library works, and that's how we can check the details with the help of our app inspection. Now we have only three fields here: name, price and ID. Let's say we have to add some another entity here, sorry, another field here. Let's say we have to add here the date when this product was purchased. Date, date of type date, and we'll take it from java.util. Okay, okay, what here is showing, expecting this one or comma. Okay, sorry, you don't need parenthesis here. Okay, so here is a date we have passed here, but what will happen, we are expecting that we'll pass the date value here and room will save that. So let's try if it works, and we'll pass date value here. We'll pass it with just a date function, and by default this date function will provide the current timestamp as an output. So let's copy this for all the fields. Sorry, copy this one, provide this here, here as well, and here as well. Okay, now we have provided the date, and I think we are good to go because there is no compilation error here anywhere. So let's try running this again. So for that, before we should uninstall our application because we haven't provided the migrations for now. Okay, uninstalling this from tutorial. Okay, and let's relaunch the application and see what happens. Okay, the application has crashed saying that error, cannot figure out how to save this field into database. You can consider adding a type converter for it, and it is showing the error for the date field. So it is clearly showing saying that it cannot figure out how to save this new data field because the room library can save only primitive types, but it cannot save this non-primitive type like date. How it is going to save? It is asking that you should provide some means by which I can understand that how to save this data. For that, there is a concept now named as type converters. So let's say how to use the type converters and what are they. Basically, the type converters, as its name suggests, it will convert, it will be an intermediary converter between our own value and our database. So basically, we'll provide some type of uh, guide to room that how to save this data and how to convert this data while saving and retrieving to and from the database. So for that, we'll create a new class here named as converters. Converters. Okay, spelling is correct. Converters here, and in this class we'll provide the converters. So if we have to provide these converters to the room library and tell it how to convert this into while saving into the database. So we'll provide some function here, function save date to, okay, yeah, we can provide save date to database, and here room will take input as a date because we have provided the date type as a date field in our entity. Here we are directly providing the date value to it, so that it should know how to convert this value and how to save that in the database. So that's the implementation we are going to show, give the room, and we'll use the method return date dot time. So basically it will provide a timestamp, and what we'll do, we'll take the value here. We'll ask the room to take that value, convert that into the long, and then save it that. So this method will return a long, and this time we are accessing the time, so that, and just click on this one. So this time get time is returning a long value. So that's how we can use it there, and the room will now understand that room will take our value whatever we have passed as a date, and it will use this function and convert that into the equivalent long, and then it will save into this database. Now in the same vice versa condition, whenever we have to access the field, then room should know also how to take that field, how to convert that into whatever the type user has defined there. So for that we also have to create another function, that is retrieve from retrieve date from database, and we'll accept the date here, but it will be of long type, and it will provide a date with the date type. Inside this we will return date, and by passing it into date as a long, so that this function is a input which takes a date in the long type, and it converts it into the date format, like this one. So we have declared the implementation, we have demonstrated the room how to perform the type conversions, but we should also tell room that I have provided these migrations, this converter, so please use them. So for that we have type converter annotation here. Type converter, we have to apply this annotation to every function which we are considering as type converter. We can declare any number of type converters here. Room will automatically recognize that, and we have to define these type converters in the database class also. Type converters, and we will just provide the class, which class is a converter, converters colon class. So yes, this is the converter class. So the database have now idea of the type converters, that how to save the data and data from the database. So, and now it will work. Where is converter class? Okay. So these two functions will do, but and the name of this function doesn't matters. Whatever the name you will give, that doesn't matters. But what it matters is what. Now let me explain how it will work. It will do what it will create this table. Okay, I have to create the name field with the string value. Okay, done. I will create a price named column with the type of double. Okay, done. Then it will come to this. Okay, I have to create the date with the type as date. Oh, I don't know about this date. Then how can I deal with that? Okay, I'll go to the database, and here database says that, hey, I have this converters class. Let's see if some converters has been provided here, so that you can deal with them. So it goes inside this class and searches for some method to convert this date into something equivalent which can be saved in the database. So it will go to this converter class, and it will search for the type converter annotation, and it will go to this method, and it can find that, okay, this method is taking date and this is giving a long, and long is something that I can save in my database, in my table. Okay, so it will automatically detect this method and it will use this method. Same, in the same way, it will search for something that okay, I have saved while retrieving data. Okay, I have here long value, but is there is something, but the user wants this in the date format. So is there is something type converted has mentioned by the developer so that I can convert that? So it will again search in the converters table, and it will now know this retrieve from database method, which takes a date as a long parameter, and it automatically converts to the whatever the data type has been demanded by the user, that is date, and it will use this function and it will automatically retrieve the data and with whatever the data type which user has demanded. So that's how this type converter will uh, happen. So let's try running our application and see if the same thing is happening here. Let me uninstall the application first, and let's see if the thing is working as per our expectation. So I'll click on the run, and yes, the records are inserted. Let's check the logcat. Okay, this is the latest one log statement here. So yes, we are able to see all the database here table, but these are the only 5 records, but these are have been spent here because of the date we have here mentioned. So this is the date, and here we can see this is the time where this tutorial has been recorded, Sunday, July 16, and it has also given the time with the GMT value and our year. So this date value has been automatically uh, generated as per our required type for by the room library with the help of these type converters. Now let's check in the database how it is actually saved. So I click on the app inspection, allow it a few seconds to load. Okay, and in the product table we are able to see the date column with this value saved as a log. So it has done the same thing just I have explained earlier. So these are the long values, and it has automatically converted the values into the user defined data type, and it is now showing in here with the help of type converters. So that is one of the most important concept that we should know as an Android developer while working with the room database. Now one simple query is remaining, some annotation that we haven't used. How to see how to use the delete product query. So let me explain that quickly. Just go to our main activity, and we'll declare here delete product instead of insert. So let's me copy delete everywhere, here and here as well. So it will delete according to the primary key. 1 2 3 4 5 records are there, and it will delete according to our primary key. Currently database has the records, and let's check. Okay, I'll clear the logcat now and relaunch the application. Application has been launched, and let's go to the logcat, and we are seeing here the product list is empty because all the records have been deleted, and the product list is empty. We can also check the app inspection, and the table will be definitely empty. It will show the table, but it will not show the contents. Yeah, product table is fully empty. All the records have been deleted. So that is about the room database, how the room database works, and how to perform CRUD operations in the room database, and how to also deal with the non-primitive types and provide the type converters. That's all the things we have learned in this tutorial. So that is about the room tutorial. I hope that is clear to you. I have tried my best to create this tutorial crystal clear and very easy to understand. Actually, room library is very easy to understand and very easy to implement. Now just go to any of your project and start implementing the room and get your hands on. and let me know how it helps you in your project. Let me know in the comments. If you have some questions or doubts, you can ask me in the comments. I will try my best to answer. If you have some suggestions for me, then please insert that in the comments box as below. Thank you for listening. If you like this tutorial, then please leave a like, leave some comments, show some love, and please subscribe to this channel for such more videos of Android specific topics. We'll meet you in the next tutorial with another some important topic and in the Android field. Till then, goodbye, happy coding.